Good morning, everyone. We are just letting people filter in for a couple of minutes, and then we will get started. All right, give people about 15, 20 more seconds, then we'll get going. Appreciate everyone showing up today. Know it's tough in the middle of the day, in the middle of the week like that, but glad you're here. Okay, let's get going. Welcome, everyone, to the Power Hour for Ground Control and Mission Planning, hosted by Propeller. My name is Nathan Smith. I am a customer success engineer here at Propeller. So if there is a problem, you generally talk to me. Sorry about that. Don't know who's controlling my mouse. Wish they wouldn't do that. But if you have a problem, you've talked to me, or if you need to figure something out, you've talked to me or my colleagues. So we will get started. So if you were at the last power, this is going to look pretty familiar to you. I'm basically going to have 5 categories that I want to go over. First off, I want to go over accuracy and consistency and exactly what that means. I want to go over our drone recommendations and kind of specifically why our lift is so small. I want to go over GCP and AP, ground control and AeroPoint best practices. I want to go over mission settings, and I only want to go over a couple mission settings because there are a lot of them. So I just want to go through a few things here. And then we'll have discussion and Q&A. And this is a good time to mention that in Zoom, there is a question and answer window. And as I'm talking here, please post any questions you have or something you want me to address. And the last 15 minutes to a half hour of this will be just discussing those questions and answers. And I'll remind everyone about halfway through again. So if you do have any questions or anything you want to throw at me, post them in that Q&A section. And if I keep looking over here, it's because I have the Q&A over here. So don't worry about that. All right, let's get started here. Now, I want to talk about accuracy, which is that first part of it, but I also specifically want to talk about consistency, which is 2 and 3 here. So we'll start with accuracy. Now, there are 2 types of accuracy that we are concerned at here at Propeller. We're concerned about relative accuracy and we're concerned about absolute accuracy. And like it says here, relative accuracy is basically a foot in the model equals a foot in real life, or a foot in a model is consistent with a foot or a meter or whatever in the model in the same model or data set. We are not comparing to an outside source here. We're not comparing to another surface, another check shot, whatever. It's just everything is consistent in the model, which means there isn't any drastic warping or changing or anything like that. Absolute accuracy is basically when we test our model's accuracy against an outside data point or data points. So a check shot that is provided when a data set is uploaded may show that there is a shift in the model surface compared to that check shot. There may be, whenever we compare against a design surface or compare against another data set or something like that, that's when we're concerned about absolute accuracy. And I have 2 examples here. So when you're doing volume measurements, if you're just doing a smart volume or a measurement inside the data set, that's a relative accuracy concern. When you're comparing your volume to a surface or to another data set, that's when we're concerned about absolute accuracy. I have a couple of examples here. So on the left, we have relative accuracy. As you can see, a foot in the model equals a foot on the ruler in the model, which is basically all we can really ask for. I mean, almost down to the 1,000th of an inch or so. Whereas on the right side, we have absolute accuracy. So what we have here are a series of check shots that were provided by a customer for the data set. And each one of those check shots is compared against the elevation of the model, and then we have a total error here. Now, when we do these errors, we usually average them together in a root mean square error, which is what you see on the bottom in red. And at Propeller, we want to keep our absolute accuracy below 1/10 of a foot or below 3 centimeters. So we're about half of that right now. So this data set is doing really, really well. And if you're wondering why that first point is a 0 difference, it's because that was the known point that the entire data set was geolocated based on. Let's talk about safety nets. Now, I know that time is money. People need to get places. People need to fly data sets. What I really want to urge people and caution people during this webinar is that we do things in a way that allows us to have a backup plan. So first off, I want you to err on the side of caution. There are riskier and easier and faster ways to do things, but a lot of times that can lead to problems. And oftentimes data sets are one-shot opportunities. So like you fly a site, the site changes, that's it. You have a snapshot of the site before it was changed, that's what you got. So getting it right that first time is very, very important. So I really want to urge you to have backup plans, or in case something goes wrong or something like that. So you can get away with risk for a long time. I've built a career on getting away with risk. But the first time that something goes wrong, it won't be worth all the time and money that was saved by risking it per se. So I really, really want to caution people in this instance. And I'm going to come back to this point more and more as we continue on. But this is kind of the underlying theme of this whole webinar. Now I want to talk some nightmares. Now, these are all scenarios that have happened to my customers. So this is not just me pulling stuff out of the air. And I want to go through these. So the first one is the long drive. Now, for a lot of drone pilots, they are either countrywide or statewide or province-wide pilots, which means they end up driving or flying all over the place. So what'll happen sometimes is you'll do a long drive or a flight or whatever. You'll get there. You need to get the flight done quickly because you got to get back to the office, back to the house, back to the airport, whatever. The problem there is that if there are issues with the data sets, you're not going to realize them until after making the return trip, which means ultimately you or someone else is going to have to make that same trip again, which is no bueno. The other one is the one-off, and I talked about this a little bit earlier, where basically they'll stop work on a job specifically for your drone flight. And once the flight is done, the work resumes and the site changes because they're doing work. Now, if you screw up the data capture, you have no way to recover the data because it's impossible to replicate that data, which means that mission is just scrapped and you got to kind of move on without it. Two more here. We have bad data. These are both kind of related. The bad data is basically when you capture data, but you don't have an outside verification source for that absolute accuracy. Most of the time, this will lead to billing issues. So either you're overbilling customers or you're getting underpaid for work. Either way, the result is panic. And similarly, if you do this and then submit it to the customer, but then realize your error after submitting it to the customer, you basically have to go to that customer, hands and knees, hat in hand, and beg and plead for them to forgive your mistake. And especially when dealing with public entities where everything on the budget is public knowledge, that can result in a lot of sadness, just like Gene Simmons there. So that was just an overview of accuracy and consistency. Again, safety net, safety net. Now I want to go through our drone recommendations here. We have a very short list of drones, and there's a reason for that, but I just wanted to do a quick overview of PPK and RTK real fast, talk about shutter styles, what drone we do recommend, and if you are flying without a recommended drone. So PPK and RTK, these are both terms that relate to kinematics, excuse me, and they're all about correcting your data using multiple data points. So in PPK or post-processing kinematics, you are correcting your information after the flight is done, which means that all the data is stored somewhere and we're able to pull it after the flight's completed and then go back and correct based on that data that's saved. RTK or real-time kinematics is data that's corrected or refined in the field at the time of the flight, hence real time. So as the drone is flying, it is correcting the photo geotags a lot of the times in real time during the flight, which sounds really good, but I'm going to come back to that in a sec. So PPK, like I said, your processing is done after the data collection is done. It doesn't require a live connection between the drone and a capture or correction station. In this case, in this photo, we have an AeroPoint, like you see behind me right there. Ultimately, this means that it's easier to correct mistakes in data collection because everything is already saved and there, and then we can massage it and mess with it to make sure that we can get a usable data set after the fact. Compared to RTK, RTK is all about requiring a live connection to a base station of some type. This can either be a physical base station, like a rover or a DJI base or any other RTK base station, or a VRS or virtual reference station, which requires a live network connection. The key part here is that the drone must maintain contact with the station throughout flight. If it loses contact with the station or it loses contact with the VRS, that flight is done. And you're either stuck with a flight that is half finished and you use what you have, or the entire flight is corrupted and you basically have to redo it. In my personal experience, I find RTK very fiddly. It's very temperamental, and there's really no way to go back and correct an error. So again, no real safety net there, unless you can check the data in the field and make sure that it's done before you go back to the office. Now, confusingly, even though we are doing PPK here at Propeller almost all the time, we do need something called an RTK module on our drones. And this is part of the reason that our list of drones is so short. Not every drone has it. A lot of almost all consumer grade drones don't have this module. So it is really confusing because it is called an RTK module, even if you don't use it for RTK. I wish they named it something else, but here we are. The other reason our list of drones is so short is that we require a very, very specific camera shutter. Now, almost all, there's two main types of camera shutters. Let me go into that first. First is a mechanical or global shutter. This is a physical shutter that opens and closes at a very fast rate of speed. This is what you would see on a SLR like you see here, or if you ever hear a camera go, shunk, that means that the shutter is actually opening and closing. The second, and these days more common type of shutter is called an electronic or a rolling shutter, which is basically just a light sensitive sensor in the camera that lines of it are activated over a period of time to capture the image. Now, the period of time may be very, 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 very short, but you're still sequentially exposing parts of that sensor to capture the information. And this leads to some problems. So on this picture, on the left side, I have a golf swing captured with a rolling or electronic shutter, and I have one captured with a mechanical or global shutter. Now, what you'll notice is that you can see it for yourself. Since the electronic shutter is taking the photo over a time period, it leads to a distortion in the data as that time period passes. Now, the most obvious thing you can see here is a spinning fan or the golf club or something like that. These are photos taken from a stationary camera with a moving object, but the inverse is true. If you take from a moving camera with a stationary object, you end up with a lot of motion blur. And what you might notice is that the brush behind the golfer there is a little blurrier than the brush on the right side. And we are really concerned with that type of motion blur when we recommend stuff. So that's why the photos on the left get a sad face. That's why the photos on the right get a happy face. So what drones do we recommend? Well, we are very heavily focused on DJI because frankly, DJI have made the drones that meet these specs. So right now, our DJI fleet includes the Mavic 3E Enterprise with an RTK module. You'll see it in the bottom right there on that photo. You can also see it behind me right there. It's that little top hat looking thing. It's very important that this is actually on the drone when you're flying with the M3 because an RTK module that isn't connected to the drone doesn't actually do anything. We also support the M300 and M350, the Matrice, which is the other big drone you see right there. That doesn't have an external module. It's built in, so you're good to go there. We also support a Wingter 1 and a Quantum. We also do still support the Phantom 4 RTK, but DJI has officially discontinued that drone. They still provide support, but like the number of spare parts and replacements and things are dwindling pretty quickly. So we have a lot of customers that are still flying P4Rs and they're still supported, but they are on the way out, unfortunately. Now, if you are flying a drone that is not on that very short list of recommended drones, we can improvise. So let's go through the two scenarios. If you're flying a drone like this Mavic 2 that doesn't have a mechanical shutter, these are the things you want to do to reduce motion blur if at all possible. You want to reduce your flight speed, and I'm talking really slow, like 5-10 miles an hour, maybe. If it has a stop and shoot mode, use that. That's going to drastically increase your flight time, but that's where we're at. You want to make sure that you're at low winds. There's no crosswinds. You don't have a tailwind behind the drone is another big problem, stuff like that. And you want to make sure there's good light. So either a sunny day or high cloud cover with even lighting. Don't do this at dawn or dusk. The other thing is that you have a drone that has a mechanical shutter, but it's not RTK compatible, like this DJI and Fire here. I don't know why there's cowboys in the photos, but the way she goes. This is a non-RTK compatible drone. So in that instance, we are going to be using regular ground control targets. And I'm going to talk about regular ground control targets in a second. The big thing is that regular ground control targets take a lot to cover the same area that an AeroPoint or a smart ground control target would. You also need to be 100% sure that those target coordinates on the ground are correct, because that's all we're going to base it on, basically, to put it in that absolute accuracy zone. The last resort is the process using only the photo geotags that are taken at the time of capture. These are pretty rough because they're uncorrected. So you could see some pretty large shifts, 2 to 6 meters, 6 to 10 feet, not uncommon when we're just doing raw geotags that are uncorrected. So that's wireless to drone. Those are short, unfortunately. Now, before I get into ground control points, I do want to remind people that if you do have questions for me at the end, there is a Q&A window in the Zoom window, and you can post your questions there, and I'll go to them after my little presentation here. So, ground control points. I'm going to cover 4 points here. We're going to talk about what style of ground control points you should use, how many you should use, where you should put them, and then I want to talk about AeroPoints specifically because they do require a little bit of extra knowledge and working. So, styles. There are a lot of styles that these are the 4 main styles that we see a lot of the time: crosshatch, reticle, the second type of crosshatch, and a cross. What's really important about all of these styles for ground control points is that they're easily seen from the sky. And more importantly, they're even easily seen from a high altitude. 400 feet, 120 meters is not uncommon for flights. So keep that in mind. They have high contrast with the area that they're sitting on. And it's easy to locate the exact center point, which actually the cross has a little bit of issues with, because that is a square area, right? So that center point could be anywhere inside there, and you're kind of guessing where the exact center is on that. If I had my druthers, I would like people to use a crosshatch style. Reticle is second, and cross is third. Stuff like chevrons or arrows or things like that are okay, but they usually end up being pretty thick, and it's tough to, again, figure out exactly where that center point is. Now, what styles you don't want to use? The first one is a little unfair because this was a salvage operation, but you don't want to use existing paint markers, or especially the corners of things or something like that, because they're really hard to pick out automatically, which means that a person is going to be picking them out manually, which means that your data set is going to have a slower turnaround time. So someone has to go in, make a judgment call on where the GCP is, all that stuff. The other ones are pretty self-explanatory. I don't know where that guy's center is. I would assume his belly button. I can't see that target. Again, high contrast. And the other one is just flat destroyed. So just keep in mind. Now, how many you want. Now, this is going to determine on what kind of survey you're running, either a block or a corridor survey. So let's start with block survey, which means a survey that is an area roughly squarish or rectangularish. When you're using regular GCPs, like one of these styles that I talked about, these are just markers on the ground. There's no GPS in them. They're just put on the ground, shot in with a rover, you have the coordinates. I like to see at least 7 to 10 per 100 acres, which is about 40 hectares. That sounds like a lot, but again, safety net. Do it right the first time, don't have to do it again. For AeroPoints, we need a lot fewer because they are a GPS collector, so they do cover more area for a given point. These are the minimum amount to cover this area. Now, that's something I really want to stress, because a lot of people have heard the 1 per 100 acres, 1 per 150 acres, and they take that as gospel and they say, oh, I put down 1, my site was only 120 acres, why are we running into problems along the edges? That's because 1 is the minimum for this area. So 1 for 100 acres or 40 hectares, 2 for 150 or 60, 3 for 200 or 80, and so on and so on and so on. Basically, just add an AeroPoint for every 20 hectares or 50 acres. Now, again, this is the minimum. I want you to use more than, because if we only use 1, that's a single point of failure. If we use multiples, we have fallbacks, we have options. We can use another one. We can, substitute something. Just gives us more wiggle room to recover a data that is usually a one-off shot, like I said. Now, these limits do apply to flat terrain, like the bottom left image, which is just a housing subdivision. The one in the top right is a mine with multiple benches, and you'll notice that the ground control points are put at different points in the topography: high, medium, low. I'm going to talk about that in a second. The second type of survey is a corridor survey. This is almost always pipelines, roadways, stuff like that, canals, stuff like that. For regular ground control points, we want one for twice the height of the mission area. So if your mission height is 400 feet, 120 meters, you want one target every 800 feet or 240 meters. That sounds like a lot, and it is. Get safety net, do it right the first time. For AeroPoints, the minimum is one per a half to 3/4 of a mile, 0.8 to 1.2 kilometers. Now, there is a caveat there where if you're doing a long corridor and the corridor, say, is 2 miles long, which is 1.4 kilometers, you want to have one at the beginning and one at the end and probably one at the center because we need to capture that start point and that end point. Otherwise, we just have that center point and the whole thing can rotate based on that. Backups, safety net. Going to keep stressing this. So if you have the option, use more. Now, what I also want to mention is that you can use regular ground control targets, just painted targets, with AeroPoints. They are not mutually exclusive. So when you're doing the data set upload, there's an option for AeroPoint plus CSV on the correction source page. What you can do is use your AeroPoint survey. So you have 2 AeroPoints and 5 regular ground control targets. You can use all of those to do data correction, and I would encourage that if possible. Now, as far as placement goes, generally there are just a few key rules here, and they're all pretty easy. Make sure you have even coverage across the site, like you have in the top right there. Make sure that it's not on the extreme edges of the area or outside the mission boundary. The points have to be inside the photo areas, and they have to be in at least 5 photos for us to use it as a ground control point. Keep that in mind. Even coverage, cover your corners, cover your centers. Now, when I talked about topography before, this is what I was mentioning. We have a mine site here, and you'll notice that we have arrow points or targets, whatever, at the top, the middle, a little lower in the middle, and the very bottom of the pit. So try to cover your vertical shifts as well if possible. And when we're talking vertical shifts, I'm not talking about a 50-foot or 15-meter shift across the site. I'm talking 300 feet, 100-meter drop, stuff like that. Big shifts or vertical images that may cause some problems. This is usually a mining concern. Okay, let's move on to AeroPoints. Now there's a little bit of extra information here. AeroPoints are smart, which means you have to be smart using. Now, we can technically get away with a 10-minute capture time. That is a very, very tight window, and I don't recommend it. What I like to see is I like to see at least a 30-minute capture if at all possible. So what I'll recommend to people is that the first thing they do when they show up to site is they put their AeroPoints out, then they go back to their truck or their vehicle, take out the drone, get it prepped for the mission, get everything on, whatever, fly your mission, get the drone back, take the SD card out, put everything away, clean it, whatever, then go get your AeroPoints. And usually by that point, I found that at least a half hour has passed, if not more. So the reason I want to increase this capture window is twofold. First off, it's because the flight has to take place inside the capture window of the AeroPoint, like you see in the bottom left image. Those 2 gray bars are the flight. The yellow bars are the capture windows for the AeroPoints. You'll see that these have been soaking for quite a while. I think that bottom one soaked for about 2 hours and 15 minutes. And that's exactly what we want to see. We want to see the flight inside the capture window. The other part of it is that you want to make sure the AeroPoints have a clear view of the sky. They are GPS receivers, so treat them like one. Don't put them next to buildings. Don't put them next to electrical interference, like a pedestal or underneath a power line. Don't put them next to metal structures. Chain link fences are a really bad one that really screw up GPS signals, stuff like that. Now, ideally, you'd want something like in the top right photo, but unless you live in Iowa or where I'm from, Minnesota, you're not going to get that a lot of times. So do your best. Just don't put them next to a wall. Don't park your truck over them. Don't put them under a tree, stuff like that. Don't put them on active roadways or haul roads because people love to run over these things. And we don't really know why. It just happens. I think they see the yellow and black and something in their brain just turns on and they have to turn the haul truck to run it over. Now, we do have an app on the App Store and both app stores, Google and Apple. And that will connect directly to the AeroPoint, and that'll give you information like its sky coverage, how long it's been capturing, what the exact battery life is, roughly the exact battery life. That's something I need to work on. What it's doing during the upload, if it's having network problems, stuff like that. So when in doubt, always use the app to check. So what you can do is put an AeroPoint down, turn the AeroPoint on, connect with the app via Bluetooth. It'll show you what the sky capture is. It'll show you if there are any quadrants that are blocked, and then you are able to make a decision based on that. So I have bad AeroPoint placement. Now, the first one in the top left is a big deal. Because a lot of people shoot their AeroPoints in at the top of the AeroPoint, they use the soil spike on their rover rods, which ends up with a punctured antenna, because that antenna is only about 3 to 5 millimeters below the surface of the foam. We have a ton of AeroPoints that have a little tiny puncture spot right in the center. So don't do that. Either use a soft tip on your rod or just put down like a coin or some kind of flat piece of plastic or something to protect the center of the AeroPoint. Otherwise, the rest of these are just kind of funny, but they do happen. It was flipped over because it was on a highway. It's on a wall underneath a tree next to a bunch of corrugated steel. Someone left their hard hat on it. A D9 dozer ran it over. That one did not survive. Again, talking about being run over. Like they couldn't hit it any more square if they tried. This one is dangerous placement because you either have a drop off or a bog behind the drop off. And watch out for animals and kids. They love to move these things. So that one in the bottom right is now a horse's toy. There he goes. Okay. Last thing I want to talk about here is mission settings. Then we can move on to Q&A. We do have quite a few questions, so I do really appreciate all of those coming. Now, there are a lot of mission settings. I want to focus on three of them, 3.5. I want to talk about ISO and shutter priority. I want to talk about flight times. I want to talk about your overlaps. Now, these are all the mission settings for an M300, like you see behind me. There are a lot of them. We have all of these in tables on our knowledge base. If you go to help.propelleraero.com or inside the platform, hit the question mark in the top right and then go to Help Center and then search for photogrammetry Mavic 3 Enterprise, photogrammetry M300, M350, something like that. We have a list of all of these things. So I'm not going to go through them. They're all important. Keep them in mind when you're setting a mission. Now, one thing to keep in mind is that the mission settings on the left are per mission. The camera settings on the right are locked to the drone generally. So every time you make a mission, you have to set the mission settings on the left. Camera settings should stick between mission, but just check them every once in a while to make sure, specifically that shutter priority. Now, you probably heard something about ISO, and mostly you've heard people complaining about ISO when you submit a data set, and this is why. For those who don't know, ISO is a way to capture an image at a low light, but with a high noise ratio. So basically increases the gain that it uses to capture the image. Now, this is great in highlight situations, but in low light situations, you end up with this really, really heavily grained image, and it's really hard to tell exactly where the center is on your ground control point. And that's ultimately what we're getting at here. We're looking for points on the ground, either to stitch the photos together or to use as your ground control corrections. Similarly, if you don't have that shutter priority or you don't have a drone with a global shutter and you fly too fast, this is what an AeroPoint ends up looking like on the ground. Now, the one on the left, I mean, that is a huge variance in where that exact center point is, and that shifts the whole model. The one in the middle is not great. We probably could salvage it. I don't want to do that, but we could if we have to. And the one on the right is exactly what we're looking for. 1/1000 shutter priority, highlight, easy to see the center of the AeroPoint. 2 thumbs up. The other thing I want to talk about is flight time. Our written recommendation is that a flight takes at least 10 minutes per battery. Anytime the drone comes back and lands, I want it in the air again for 10 minutes when it goes back out. Like I mentioned, these fall inside the AeroPoint capture. This is actually the same image I used last time. But this really allows the GPS and RTK modules to initialize and capture enough satellites as the drone is flying through the air. This is very, very important. If your flight time is going to be under 10 minutes, the easiest way to do this is just to reduce the speed of the mission. The other thing you can do is take the drone off, let it hover for a little while, a few minutes, and then start your mission as it's hovering. I prefer to reduce speed, but if you have a really, really small mission, then the hover and takeoff may be the best way to go. Now, you also will run into an issue where you have, say, a 4-battery flight, and the first 3 batteries are 20 to 25-minute flights, and the last one is, say, 5 to 6 minutes. That's actually okay. That last one is usually a minority of the data anyway, and we can get away with that. If I had my druthers, I would make them all take 10 minutes, but if you submit one with a short flight at the tail end of the mission, especially if it's only like 5 to 10% of the mission, we can usually get away with that. Now, that said, again, safety net. Can get away with it. Maybe not always a great idea. This is just another instance of flight time here. So we have our 2 flights here. This is a 2-battery flight. First flight was 20 minutes, second flight is 6 minutes, and there's a GPS quality. This is a little arbitrary, but we do base this on like satellite captures, cycle flips, signal noise ratio, stuff like that. So 20 minutes in the air gives you good GPS quality. 6 minutes in the air gives you bad GPS quality. What I have here also is what we call a sky plot from the drone's point of view of the satellites that it can see. Now, what you'll notice here is that we have a lot of lines without a lot of cycle slips, except for those C satellites, which is actually okay. Those red lines on the C satellites are what we call cycle slips, which means that the drone lost the satellite at some point. And if you see a lot of those on the sky plot, that's bad. That means that the drone had no time to capture satellites. The satellites that did capture were really inconsistent. You know, if a drone flies underneath a power line or something, or the AeroPoint is set under a power line, we'll either see one of these quadrants like blocked off, or we'll see a huge cycle slip where that interference is. So this is the other reason to keep the drone in for that long. One thing I do want to mention with wing drones and quantums, since they are fixed wing drones, when they bank, they sometimes will lose the satellites because they are banking pretty steeply to hit the next leg of the flight. That's generally been okay, but we have had instances with wing drones where the flight area is so tight that it spends so much time banking that it doesn't have time to pick the satellites up again. So always err on the side of giving your wing or quantum time to bank and come back into the mission area. Wow. Okay, last thing I'm going to talk about here is overlaps. And the reason I'm going to bring it up is because the M3E is a little different than almost every other drone we recommend. For the M3E, we recommend an 80-80 side and front overlap. You can get away with 75-75, but it's not ideal. Anything lower than that, and you're running into issues. For everything else, the M300, the Phantom, 75-75 is about standard. 70-70 is possible. Anything lower than that, 65-65, 60-60, anything like that. What you risk is the inability to stitch the model together because we can't find enough common points between the photos to stitch it. And we end up having to do it by hand, and it takes forever. What a lot of times this ends up looking like is just gaps in the data, where you'll just see a hole in the data. So the model surface is not watertight, just a big old hole that you can see right through, and that's bad. So this generally, the higher your overlaps, obviously the more photos you're going to take, but generally it's worth taking more photos at a higher overlap to avoid losing data, like I mentioned multiple times, is irrecoverable. Irrecoverable. So that was my spiel. This is the Q&A portion. Again, if you do have a question for me, we've got almost a half hour. Post it in that Q&A section, and I will get through it here. So first of all, I'm going to stop sharing my screen so you can see my lovely face. There it is. Okay. I'll just start going through these. I have set up a known point using about 8 or so AeroPoint flights with propeller correction network and taking the average. Is this reasonable, or can there be a systemic error with the propeller corrections network? It is reasonable, especially with that many flights, that you are going to get a good capture on that known point. I would say if you were doing 1 or 2 flights, then there could be a problem with the capture, especially if the base station that you're using near you is spotty, which some of them are. Some of them don't report once in a while. But for the most part, if you've flown that many times, that known point should be pretty solid. And you'll notice any outliers when they show up if the known point's having issues. Does PPK with an AeroPoint on a known point work if it is a few hundred meters outside the survey area? No. And when we're talking about survey area, I'm talking about the drone mission area, not the actual project area. So if it's outside your project area, but it's still within the drone mission area, then it will work. If it's outside the project area and the mission area, you're kind of out of luck. Especially with a few hundred meters, it may show up on a corner of an image here or there, but not nearly enough to use it as a ground control point. We are still using the Phantom 4 RTK. Besides battery improvements, what else will we gain by upgrading to M3E? Accuracy? We kind of go back and forth on this. Realistically, the accuracy is going to be pretty dang close, within a few percentages of each other. Really what you're getting when you're upgrading the M3 is, like you said, battery and flight improvements, ongoing support, since they are actively supporting it versus the Phantom, which is being sunset or end of life. It also handles wind quite a bit better than the Phantom 4 RTK. So, the Phantom 4 RTK we recommended, like, don't try to fly anything over 20 to 25 miles an hour. The Mavic can, excuse me, Mavic can take about 25 miles an hour. Anything over that, you're still a little sketchy. But because it is so much smaller and more less cross section than the Phantom 4, it handles wind better. The piloting software I find is also a little more reliable, and it's easier to plan a mission on it. Also, the controller is way handier to use, to be real honest. Any other recommended drones coming up? We do have a few irons in the fire. We are working with Skydio. We are supporting Autels and Anzus for the time being, till that whole thing goes down. And then we have a whole list of drones that we are currently vetting right now. It is really tough because, like I said, the two qualifications we have are RTK capability and that global shutter. And those are pretty rare outside of DJI or like small boutique things. We are also looking at a Whisper as another one that we're looking at. Did I attend Dimensions? And if so, did I have a good time? I did not attend Dimensions, but some of my coworkers did, and they said it was a lovely time. Although I can't help but notice that they broke the wheel on one of our carrying cases. So I have to have some words with them about that. I mentioned a certain measurement of 0.16. It was actually 0.016 on one of the first slides of the presentation. I didn't catch what the slide was talking about. I wonder what that was. That was a measure of absolute error. So what we had is a series of 4 known points that were shot in with a rover or collected with an AeroPoint. And that 0.016 was the total error across all 4 points. One was 0, one is a little high at 0.04, and the 0.016 was the average error across the site. That was in centimeters, so that's 1.6 centimeters, which is very good. Threshold is 3 centimeters or a tenth of a foot. You can find that in your processing report on your data sets under outputs and then processing report. What does the RTK module actually do? I have removed it and powered the drone on in the past and haven't noticed a difference in satellite reception if you fly with RTK off. Generally, what it does is allows a better satellite connection as well as an L1, L2 connection, which is a bandwidth for GPS satellites. You will notice on that skyplot, some of those are blue and some of them are green. Blue meant that we had an L1 and an L2 connection. Green meant we only had an L1 connection. That's generally what it's there for. It also allows VRS capability if you are using that. Otherwise, that will be disabled in the drone software if it doesn't see that an RTK module is connected. Or you can't connect to an RTK base station if you want to fly RTK. Can I review the GCP examples again? Sure. Let me just bring her up here. And we'll back her up. Back it up. Back it up. Okay. So the styles, again, what I recommend is if you're painting your own ground control points, I recommend crosshatch or reticle. Cross is okay. It's the easiest one to make. You just paint it out. You put a couple pieces of glass together. But hitting the exact center point is kind of tough. Don't use one of these. That's generally what I want to get at here. When combining GCPs with AeroPoints, how many of each should you have per 100, 150, 200 acres? Depends on how many AeroPoints you're using. Let's say 200 acres, we'd recommend 3 AeroPoints to capture it at a minimum. Again, that's the minimum. I would want to see 4 or 5, to be real honest. But if you're using 3 AeroPoints at 200 acres, you could add, say, 4 to 5 regular ground control points if they're out there. Basically, if they're out there, you can add them. That's not, I mean, if they're already there, use them. If you are doing like 2 AeroPoints and you're trying to do 100 acres, then I would go by that 7 to 10 per extra 100 acres you're adding, kind of a deal. So always err on the side of adding more than you think you will. You can always add, we can always get rid of a ground control point in post-processing. We can't add a ground control point. I use 1 AeroPoint for our largest pit. It is around 200 acres, 80 hectares. If I were to add another AeroPoint, how would I add that in the data processing? So it'll only let me pick 1 AeroPoint. Kind of. What it does is it requires you to pick 1 AeroPoint to use as the anchor point or the known point. The other one will still be used in reference to that known point. So it's only asking for 1 for the coordinates for 1 during the upload for known point style, but it will still use that extra 1 as long as it's capturing at the same time. So redundancy. It may not add specific accuracy, but it definitely makes it a heck of a lot more consistent. And especially in areas that are very far away from the AeroPoint, it's going to reduce distortion. Because the reason I want to talk about coverage across the site and even coverage is that the Earth is curved, right? I think it still is. So As a model is flat, if you don't have something pinning it down to the surface of the Earth, the model will continue as the surface curves like that. So you're going to end up with some pretty bad distortions away from that ground control point. The other way to think about this is like a tarp. You don't tent or you don't stake three parts of a tarp, right? The other part's just going to do this. And it's really annoying when you're trying to sleep. The more ground control points you have, the more stakes, the tighter the model is to the surface of the Earth. If flying a stockpile, is it recommended to put an AeroPoint at the top of the stockpile? I would rather not put an AeroPoint at the top of the stockpile. First of all, because you got to go up and get it, which means you can disturb the top of the stockpile and screw up the ground surface. Secondly, it's just, you don't really need to, unless the stockpile is 200-300 feet tall, which if it is, there's bigger problems there. Just place it around the outside. And specifically, if you're only flying one stockpile, you can put it at the toe of the stockpile, make sure it has good sky coverage, and you should be good there. Can I talk about leapfrogging with the AeroPoints to cover larger areas? Yeah, so this is something we see on corridor projects. So when we talk about leapfrogging, what we'll do is say you have 3 AeroPoints. 1, 2, 3. That third AeroPoint, you're going to continue on past that with surveys. So what you want to do is leave that third AeroPoint running and then move the first 2, turn them off first, and then move the first 2 to this side, and then repeat. So that third point is your anchor point between the 2 types, and you're literally leapfrogging it over like that. For exact missions, this usually ends up being a little trickier. So I definitely recommend you reach out to your CFE or check the knowledge base article on leapfrogging for specifics. What is the name of that app for AeroPoint checking? It is just called AeroPoints. If you search in Google Play or in the Apple iStore and search for AeroPoint, or if you search for Propeller, you're either find that or our mobile app. I recommend use both. Mobile app is for seeing data on your phone. Yeah, this AeroPoint one is specifically for connecting to AeroPoints. So search Propeller or AeroPoint, and we'll have the big trademark black, white, black, yellow crosshatch style. How do I know if my shutter is mechanical or rolling? Generally, this is going to require a Google search unless you know off the top of your head. Dollars to donuts, unless it's one of those drones I mentioned, it's probably a rolling shutter. But generally, you can Google a shutter. Like for that Inspire drone I showed, doesn't have an RTK module, but the camera it's using, which is a Zeiss X7 I think, that does have a mechanical shutter in it. But I just had to Google it, look up the spec sheet. Almost all cameras will say what kind of shutter they have. If you see the word CMOS shutter, that means that it's a rolling shutter, because the CMOS is just the actual chip. Complementary metal oxide semiconductor is what that stands for. What is the horizon tolerance on the AeroPoint? Example, how close to vegetation, guardrail, pile of wood before I start to see errors in processing? 10 feet away, 20 feet away? It's actually based on angle. So what we want to see is, we don't want to see anything above a 15-degree horizon from the AeroPoint's center point. That's pretty low, and this is real life. So do the best you can. But if you want to follow by the rule, well, the letter of the law, 15 degrees up. So what you do is you find the newest kid on site who doesn't know any better. You have him put his face on the AeroPoint. You put a angle meter dealie, I can't remember the name of, and you just have him rotate his face up and see if there's anything blocking his line of sight. 15 degrees. First off, this is just good fun. And second of all, it's the best way to tell. But again, real life, do the best you can. The biggest thing is just not putting it next to an object that blocks like half the sky. So like I mentioned, your truck, a lot of people love throwing it right next to their truck, and then that truck blocks everything, as well as providing a big GPS interference with all the steel in it. We're going to see how accurate individual areas are on a site that may not have had a great spread of ground control points. So this is going back to that absolute accuracy discussion. What you want to do is you want to compare it to an outside data point. So if you have check shots on that site from, say, the building plans, the survey, or whatever, that's the first thing I would try to check. And you can upload those as what we call checkpoints. Even if they're not physical targets on the ground, when they're uploaded as a checkpoint, we store the coordinates and give you the error between the model surface and that checkpoint. Otherwise, what you can do is put a measurement down if you know where the check shot is. It'll give you the exact Z value for that point measurement, specifically probably elevation history or point of interest. And then you can compare that to the Z value on your checklist or checkpoint list and see the difference there. The other way to do this is to compare to a previous flight that you know turned out really well and see what if there's any shift between the two model surfaces like this. What'll happen a lot of times is we'll end up with something called we call bruising or warping, where we'll notice a little like systemic shift between the model surfaces. Is there a plan for the Autel Evo 2 V3 to become compatible with propeller software? Yes, there is. It is currently in progress. We are actually making very good progress on it, and I would expect to see that released relatively soon here. Any suggestions on AeroPoint placement on existing survey monuments? This is going to depend on where the monument is. If the monument's in the middle of the road, where a lot of them are, unless that road is closed and you have control access, I would recommend against putting it on there. If it's on a sidewalk, that's okay. I have had AeroPoints walk away when someone put them on a sidewalk that was publicly accessible and people picked it up and walked away with it. It happens. So keep that in mind. The only other real criteria there is to make sure that that monument is flush with the ground. You know, if it's a monument where they have a pad of concrete like this, and then you put the AeroPoint on top of that, the AeroPoint is going to assume that the top of that pad is the ground surface because we want it flush with the ground. So don't put it raised up like that. Keep it flush with the ground. Otherwise, wherever you put it is fine. Since the monument, a brass cap, steel cap, or whatever, is usually underneath the AeroPoint, you're not going to get any interference from that little bit of metal under there. What's the best way to deal with ISO if it's a cloudy day? Would lowering your height help? Now, I do want to clarify this because cloudy day can mean two different things. If you have high clouds but very even lighting and it's not a big deal, you can usually get away without messing with the ISO or having an ISO problem. If it's really dark or low clouds, first off, you might want to consider not flying because it probably means you either have fog or a storm coming in. But what I would do then is slow down the drone. You can mess with the shutter priority speed, change it from 1 to 1,000 to 1 to 750. But just know that when you lower that speed, that drone has to be going slower. Otherwise, we're going to get motion blur in the image. Basically, what the shutter will do is it'll just open for a quarter of a second longer, actually, quarter of a second, I think, and then allow more light to get to the sensor before closing again. So it's just like the rolling shutter. It's open for longer, and if the drone's moving, that introduces more possibility for motion blur. Does flight time start with drone in the air or after the first image captured? Both. So the way that our uploader checks flight time is that it looks at the first image timestamp and looks at the last image timestamp and compare it, sees how long that is. Technically, it starts when the drone is in the air. So if it takes the drone 45 seconds to fly to and from the mission area, that's added on to the flight time. You may still get the short flight warning in the platform, but you know that there's an extra minute and a half on that. So if the flight time is showing up as 9 minutes and you know that it was flying for a minute and a half, your flight time is actually 10 minutes and 30 seconds. In what scenario would I change ISO? 800 cloudy and dark or 1200 bright and sunny? I would almost never change ISO. I would always leave it on automatic if possible. What I would change is the shutter priority of the exposure value if possible. And that's getting more into like camera terminology, which I'm not really good at. I'm not good at a lot of stuff. That's one of them. Generally, if we see an ISO over about 400, 600, or 700, we're a little concerned about the image quality. So we want low ISO. Do I have a recommended flight speed, mile per hour, for the M3? Default flight speed for the M3 on a mission is 33.5 miles per hour. I'd say as long as the conditions are good, it's not cloudy, light's good, there's no wind, you're flying parallel or perpendicular to the wind like you should be, max it out. The only other considerations are wind, how long the drone is in the air, and the lighting conditions to make sure that the photos are good. But that 33 mph is generally as fast as it'll let you go, and that's kind of what I recommend. The quadcopters are kind of unique because they will slow down to not overfly how fast the camera is saving images. This is called trigger time. It is an issue with the fixed wing drones because they fly at a single speed. For the wing chart, I believe it's 16 meters per second. So they can't slow down if it's taking longer to save images. This is also why we recommend using a fast USB or SD card in your drones. Can you explain more on why we need an RTK on the drone to turn it off? Yeah, so one of the little quirks there, like I said, is that the RTK module is necessary, but running RTK is not the greatest idea. And on a M3E or an M300 or a P4R, there's actually a specific setting in the controller that says you use RTK and we want that disabled. That setting is looking for a base station. So even though we are using the RTK module to increase GPS coverage, better signal noise ratio, all that stuff, we're not running an active RTK setup, so we want that setting disabled in the advanced settings. And our knowledge base goes into that as well. Can an AeroPoint shot taken with a GPS server be used as a checkpoint when processing data? Yes, it can. And a lot of people will do this actually. So what they'll do is they'll shoot the AeroPoint for their known point, top or bottom, whatever. And then they'll actually upload that point again as a check shot, just to make sure that there isn't any shift in between what they shot on the AeroPoint and what the model is giving them for a surface. Have you considered making the AeroPoints just a little bit smaller so they fit in carry-on luggage? As you mentioned, many people have to fly them for a short trip. This would help eliminate checked luggage, risk cost of baggage, and the potential of it getting lost. We have thought about it. As a joke, we made what we called the cutie point, which is only about yay big, foot by a foot or something. It worked. It's really hard to pick up targets that small from altitude, and that's the main reason that they're as big as they are. I think we can get away with making them a little bit smaller, but we found that this form factor really works out well for being seen from altitude. I just got my working. Oh, sorry, Cody. Is there a way for us to view that satellite map on the previous slide? Not yet. I'm pushing very heavily for it because that is something that you could use to check both your drone's GPS capture and the AeroPoint's GPS capture. It's actually even more useful on the AeroPoint because then you can see if there's an obstruction blocking it or something. So not yet. I'm pushing pretty heavily for it. Anything different for L2 LiDAR capture? Generally, with LiDAR, you're going to have a lower overlap, probably like 40 to 50% overlap versus like the 80% overlap with photogrammetry. But the rules still apply. Have enough coverage. Be careful about flying over snow, water, or very bright sand with a LiDAR because you could get spikes in data as the laser literally bounces off the surface. Why does the Mavic require a higher overlap than the other drones? Because the Mavic has a wide camera rather than a 4x3 camera like the other ones do. So if you look at the photos, they're actually a little bit wide. And we need more of that side overlap to get them to overlap correctly. We also recommend turning on distortion correction for the Mavic, which we generally don't recommend for the other drones. For the Wingtra, is 80% overlap optimal? I would prefer to see that. Not necessary, but I think that's a good starting point. Will we receive the presentation slide in addition to the recording? I don't know. I'd have to clear that. I don't see why not, but I will have the recording up so you can kind of go through them to check it out. How many pads would I use for a Walmart? It's going to depend on the size of your Walmart, isn't it? Generally, if you're looking at the parking lot too, I think one would be fine as long as you're pretty far away from the building. That's the minimum. Again, safety net. I would prefer 2 or 3 if possible, just to have backups. Pausing mission to achieve needed flight time is okay, question mark? Yes and no. The reason I didn't recommend this is because it's been a little spotty. Sometimes what'll happen is you'll pause the mission, hit resume, and then it just forgets where it was on the mission. I prefer not doing this. It is possible. It was recommended at one point. So I'd rather just let it hover for a bit and then start the mission and finish the mission in one shot, or just slow the mission speed down. How are you checking that your AeroPoint coordinate and elevation matches to the local datums? 2 ways. This happens at site creation or the way the AeroPoint was processed. So when the AeroPoint is processed, if you're using a known point, we are relying on your northern, easting, and elevation. So it's going to be on you to make sure that your data collector or however the shot was put in is in the right coordinate system, including the vertical and horizontal datums. If we're doing a global point or a corrections network, which is an automatic processing, those will be in published coordinate systems most of the time. And those are just standardized coordinate systems with standardized vertical datum. So here in the States, it's very common to use NAD83 state plane 2011 version and a NAVD88, or NAD83 is the horizontal, NAVD88, geoid 12 Bravo or geoid 18 is the standard for the vertical datums. And those have definitions, and we have known spots specifically from the base stations because they're all set up the same way. If my site is very small, can I only use one AeroPoint or do I need at least 3 AeroPoints? You can get away with one. I would prefer to see 2 just to have as a backup. 3 might be a little bit overkill, depending on how small. I mean, if we're talking 5, 10 acres or so, you can get away with 2. Is there such a thing as too many targets in a flight? For example, is it bad for the model if 2 targets show up in a single image? No, to an extent. We have had people that have uploaded like 400 ground control points, and that's just so much data to process that it slows down the machine doing the processing. Generally, as long as you're in double digits, you're doing okay. I would say anything above 50, unless you're flying a truly large area, like over 1,000 acres. More like 800 acres, 700 acres. Anything over 50 is overkill. And then you can maybe consider downgrading some of those just to regular trick shots, unless you really, really want them, in which case. If you fly the same area often, should you move the AeroPoints around different points or use the same layout each time? I would prefer using the same layout each time just because if there is issues flight to flight, that takes out one possible variable. We can say, oh, the AeroPoint's in the same spot every time. That's not our issue. Move on to the next step of troubleshooting. If you have to, you can get away with moving on. I prefer to keep them in the same place, which is also why I recommend putting AeroPoints on a spot on site, specifically for earthwork sites, that is not going to be disturbed during the project, if possible. We do have some jobs up where there are already houses built and needed to be surveyed. The site looks so busy to place the AeroPoint. What would you recommend? Thanks. Thank you. Do the best you can with getting a clear view of the sky. If that involves putting it in the middle of a road or a cul-de-sac or something like that, make sure there's no traffic going over that because they will run over the AeroPoint. Again, don't know why. Otherwise, if you have to put it next to a house, keep it as far away from anything as you can. Use that app to check your coverage, like I mentioned, and just do the best you can. You may require putting the AeroPoint down and checking the coverage in a few different spots, or making some kid put his face on the AeroPoint and go 15 degrees up. Should we keep the known point of a flight for the upload, or are we better off using our CSV corrections for the upload? I would keep the known point if at all possible. Again, we can always disregard the known point, but we can't add it in later. We'd have to we can add it in later, but it requires a lot of manual processes. So more data is better. Does the 10-minute rule apply to a drone that stays powered during battery hot swaps, such as M300 or M350? Generally, yes. I'm always a little leery when they're on the ground and you're hot swapping batteries because it's going to reduce power state on a battery that's also partially drained. I would err on the side of caution here again. Theme, stick with the 10 minutes in the air flight time. When using a known point, does the AeroPoint need to be placed 10 minutes? Technically, no. Realistically, yes. Because if there's any issue with that capture at all, we have no wiggle room if it's 10 minutes or below. So it has to be dead on the first time. I would recommend doing more if possible. What would you recommend shooting in an urban setting surrounded by high rises? Is it recommended? That's tough for a couple reasons. First of all, urban areas with high rises are generally going to have tighter airspace restrictions. So you got to keep that in mind and make sure that your airspace ceiling is higher than the tallest building. Otherwise, your AeroPoint or your drone's just going to go and run into the building, which is bad and has happened. If you have a parking lot nearby that maybe is a little bit outside the project area, but it's a better shot, use that, expand the mission boundary to capture it. Otherwise, do the best you can. Again, roads, if you can block off the traffic, any kind of open space, if at all possible. I would resist the urge to put it on top of buildings, if at all possible, because like I said, we assume that the AeroPoint's on the ground. So you could do some redneck math where you put it on top of the building and subtract the height of the building from the AeroPoint's height if you're using a known point, but there's a lot of leap and logic there that I'm not very comfortable with. Would a spray painted X on a manhole serve as a sufficient ground control point? Yes, as long as that X is dead center on the point that you're trying to shoot in. So just keep that in mind that we want the dead center of it and try to use, if at all possible, I try to use that reticle design where you have like a gap between the center and the rest of the line, but across will work. Okay, I got time for one more and we are at time at the top of the hour. So last question. We had someone run over one of our AeroPoints a few months back. all the time. Is there a way to test for potential damage or increase in accuracy? It seems to work all right for now, but could there be lasting issues? How resilient are they? They're actually pretty dang resilient. The best way to check for inaccuracies is just to do a big long test capture. Throw it outside, leave it on for a few hours, come back, ask your CSE or hardware to check the GPS information, that sky plot, the signal noise ratio, all that other stuff, how many satellites it's seen, how many cycle slips, all that stuff. If that comes back fine, you should be good to go. The big concern with running over AeroPoints, I'm actually going to grab our extra one here, is if this quadrant is damaged, that's where the battery is. And you'll know right away because it'll probably start on fire if you try and turn it on. So running over this quadrant is generally okay. This one's okay. This is bad because that's where the antenna is. This is where the solar panel is right here. This is where the lithium battery is. So if someone runs over it like this, these are pretty resistant foam, so it probably will survive the trip. But I have, and it also depends on what ran it over. I've had a lot of them where they get run over by like a car, a coupe, something like coupe, if you will, something like that, and they're totally fine. If they get run over by a dozer or anything that tracks or anything that's really, really heavy on small wheelbases, that's going to run into problems. So I had a lot more questions I didn't get to here. Super appreciative of everyone that came in. I'm so glad these are become so popular. I appreciate all the questions. Only got about halfway through these. We are going to record these questions, and if they are like very customer specific, we can have your CSE reach out to you and talk to you about them. Otherwise, reach out to your CSE with specific questions. Of course, they pay them. So again, so glad everyone showed up. The numbers we're getting are insane. I'm so happy. And that was the Propeller Power Hour for ground control and mission accuracy. Thank you so much.